Let me know if people can hear me. For those of you who don't know me, my name's Cara. I live in Moab and have been working in Tamarisk and Russian olive projects for quite a while, for about 15 or more years now. And around 2004, I think it was, the leaf beetles were released in the Moab area. And made rapid gains and moved around very, very quickly and created a lot of fear, really, especially as the river corridor would brown in different sections. And so by 2006, there was a lot of tamarisk being removed relatively quickly on private and public lands. And so there was a lot of sort of, gotta do something, a lot of motion. And a lot of us in the Moab area were really worried, not worried, but wondering, what's going on here. So we started a data collection process that has been going on now for 6 years in the area. There were some questions. Overall question really is how successful, and defining success is a challenge, but in terms of tamarisk reduction and native plant increase, how successful are these local projects? And then there's a whole slew of other questions. And also at the same time with all these questions, there's no funding. And so we went ahead and did some data collection anyway, came up with a program anyway, did receive some great support from the Walton Foundation, Forestry Farm State Lands, and Nature Conservancy in Moab, though there is no funding yet secured for this year. We'll see where we go with that. But it is sort of an ongoing process. It takes a lot of time. We did start with a literature search and came up with some different things we wanted to try to get some quantitative information on, and also just gather information about what are people doing. We have about 100 river miles and a lot of different treatments happening, some by accident, some on purpose, and so why not try to track this a little bit. The main data we've been collecting is line intercept transects. On small sites under 5 acres, there's 1 transect per site. On larger sites, we have some sites that are between 15 and 30 acres. On those sites, we have more transects. We also took soil samples in 2011. So Phillips helped us out in the beginning with some of our planning on this, and I remember sitting in my living room joking with her about, we'll get to that when we have money. It won't really change much unless it floods. Well, it flooded in 2011, which is when we finally got our soil samples. But you do what you can. This could not have happened in the last few years, especially without the Utah Division of Forestry, Fire, and State Lands, Walton Family Foundation, and some private support. And there have been a lot of people over the years who have been hugely helpful in collecting the data and slogging through incredible temperatures and mosquitoes and mud and all the rest of it. So huge thank you to a whole slew of people out there. So here are the sites we've been monitoring in the Moab Valley. So Nature Conservancy here, there's 900 acre preserve up here. That site is not really comparable to anything along Mill Creek or in town or along the main river. But a lot of the rest of these sites go about 2 miles up creek here, and then we're working on Flat Creek as well. And we have a few sites way up Flat Creek. These I'm not going to talk about today, but there is a whole lot of information we're working through on these sites. Let's talk today about the main stem. Up here, this is the Dolores River. Down here, that's the potash plant. So for those who might be a little familiar with the stretch of river, the boat put in for cataract is right down in here. The Moab Daily runs roughly from here to Takeout Beach. And there are 14 sites that we are monitoring. 4 of them are private, and the rest are on BLM. And they are mostly slightly larger removable areas. Most of them are larger than an acre by quite a bit. Some of them are as big as 30 acres. We're going to start with Cottonwood Bend at the mouth of the Dolores River. This site is really complicated. Everything that I've read about monitoring on the river says we shouldn't be monitoring this site. It's at the confluence of another river. There's a lot of geomorphology going on here. It's really complicated. But we have a willing landowner. It's a large site. And for our purposes, we felt like it made sense in part because it's complicated. So we go to one site, and we have 5 transects in different areas of the site. Maybe we can learn something there. So there's 30 acres, 5 transects, and we've been collecting here annually for 6 years now. This site started with an accidental fire, which is what I mean by some removals of accident, and then was followed up with biomass mastication with Tamarisk, and then re-sprouts treated, and a little bit of knapweed treatment. But otherwise, there hasn't been a lot of vegetation manipulation on the site. Both of these photos show a couple of transects in 2012. Sorry for the blur. This is the best aerial I could find. 2001 at the same scale as the other ones I'm going to show you. This is and pre-fire. And what you'll notice in part about this is probably an old channel. That's where most of the Tamarisk was, although it's scattered throughout. I think that these here are mostly willows, even at this time, but I don't know that because I didn't actually go out and look before this burned. This is the site immediately after the fire and some biomass mastication. The one transect right in what was probably an old channel. This is sort of semi-uplandy. This numbers 3, 4, and 5 have flooded multiple times since the removal. So, whereas these haven't. So it's kind of an interesting, a lot going on here. Here's after re-sprout treatments. You can see the site's largely empty. We also got in here and did some more mastication, and you can kind of see we ran out of steam. That area didn't have much done, and actually that area doesn't have what Tamarisk going to need. It's kind of interesting. This is during some of the higher water in 2009. You can see the damp soil in places. This is in high water 2011, so you can see this transect's underwater. This one soon will be. And then this is drought year 2012. So, what did we find? We have, these are some of our very simple graphs. We're not scientists. We're doing the best we can to collect some good information that hopefully can help inform us a little bit better. But these are some simple summary graphs. A little bit hard to read. We're very much in the beginning process of this, so hopefully soon I'll get this a little cleaner. But note these scales are not the same on these different transects. I wanted these to be visible to you because when you have 300% here, that's shooting some of your stuff off the chart, whereas over here you can barely see it. What we're collecting in our transects is ground cover, shrub level, and overhead. So that's why you can have 200% cover. Haven't done a whole lot of manipulating of the data. There was some basic summaries at this point. One of the important things on this slide to notice is collecting both dead and live cover. Part of that is because we only can afford to get out here once a year to these sites. And you can't, a lot of annuals, if it's a spring annual, summer annual, fall annual, you aren't going to catch it. So that information in part to get a sense of if we're having perennials die, but also to try to capture some of that annual information. We may not get there when the bee plant's going, so it's good to know that it's there. And so then the other thing on this site that's interesting, these slides show native species, annual and versus perennial species. You see there's a lot of variability with annual species. For those of you who work with vegetation monitoring a lot, that's kind of but annuals change, they move around, they change a lot. Perennials are a lot slower. They're the last to really show changes sometimes, and they're also, those changes tend to be much more slow. And what you'll notice in here, and I'll show on the next slide, next site, we'll get into some of the specifics specifics on what these species are, but there's definitely a difference in how the annuals and perennials are acting on the site. And these are the exotics on the site. And you'll notice here, we still have extreme variability, and the exotics, what I'm noticing, are tending to be more annuals across the board, whereas our natives are tending to be more perennials. At first I was thinking maybe that's just because I don't know my native annuals very well, but the more that I'm looking at this, I think we actually are catching a lot of them. We do need to get a little more complete with how we're looking at the dead and live, but for now we're just splitting them apart. On this site, we're seeing a lot of bebong, bigweed, asters, and then the perennials, you'll notice, are a lot of grasses. Even though the site's right on the river, and some cottonwood, tobacco, and a lot of gumweed. The annuals are largely, kochia is the most dominant that you see on the site, but you also have some cheatgrass and thistle, and then actually more perennial exotics than I would have thought. But this site too, if you remember those aerial photographs, this site really probably won't ever have more than about 30% cover on the bottom. It's just not going to happen. So now we're going to back out, big picture again, and shift on to our next site, and that is at Vita Gulch Rocky Rapid. For those of you who are familiar with this area, this is a very active recreation spot. There are 7 transects I'd like to say by design, but it kind of was accidental, on about a mile of the river, where there's a whole lot of different beetle and mammifal areas. And actually, when you see the map, it was kind of amazing. This is kind of nice. There's a lot. We've got a lot of monitoring going on in an area with some variability here. The trees were cut in 2004. The piles were burned in 2005. There were a variety of things going on at the local BLM at the time, so I don't believe that the Tamarisk were ever treated with any herbicide. And there have been no treatments in these areas other than napping since then. We've collected data for 5 years. One thing we figured out is annual data collection is probably overkill. So now we're shifting, especially with funding constraints, to 3 years on a lot of these sites. So this is one of the sites that did not have collection last year. So here's the site. Notice the sort of stippling effect. Those are all the Tamarisk piles. It starts up here at a private place called Dohrenwend Ranch. It's all along this curve. This is a kayak sneak boat. Then you can get in. There's the main boat takeout, and then there's a island you go around, and then these are very tiny little benches that are almost never used. So this site and this site have huge recreational spots. These 2 sites and these 2 sites. This is after the piles are burned, and you can start to see resprouting already. Here especially, this area is this is more on a bench, so it's a little bit different. Here's 2009. A lot more water in 2011. Bunches, parts of this site. I'm not 100% sure. I don't think this was actual high water. I think some of this actually did get covered with water that year. And then here's last year's drought. So here, what I found interesting, and don't really know why yet, you never know why, but the Vita Gulch transects, those are the downstream transects, those are generally pretty diverse and have what I would maybe call some pretty Tamarisk is there, but not lots. Whereas upstream, you have diversity, but it's mostly dominated by those resprouts. And the native plant numbers seem to kind of be around where they were, or the percent cover seems to be kind of close to where it was before. Here's an example of Vita Gulch A. That was the most downstream site on those areas. This site, I think is kind of interesting. Your annuals, your natives pretty much stayed the same. I wouldn't call that much of a significant change. And then this is driven mostly by Tamarisk sprouting, and that sort of stayed the same as well. Vita Gulch D, this is the one that downstream just a little bit. This one I find interesting because your live exotics, stay below 20%. Your live natives are significantly higher, but that's also mostly driven by one species, and lots of that's down here with all the others. But there's quite a bit of diversity here. 2 annual species, all the rest of these are perennials. And then here again is our dead natives that we're seeing. Bee plant definitely is on this site. Exotic cover on this site. So now I'm changing scales a little bit again. 90%, 25%. We don't have a lot of live exotics. Here are your annuals. Here are your perennials, and again, they're driven mostly by Tamarisk. This is Rocky Rapid, so this is just above the rapid. Transect number 3 is the farthest upstream transect, so this has almost no, recreational impacts. This is another site where the Tamarisk has come back. And you also have much less diversity in your native plants than in your non-native plants. Completely ignore that line. I looked at that again this morning and realized so forget that one. but your exotics have quite a lot of annuals. Kochia being one of your main dominant, and then Tamarisk race routes, of course, in that area. What I think is interesting is we're still under 60% on our Tamarisk cover, when before it was most definitely 100% cover there. So, what have these data shown us? These are 2 sites out of our 14 on the river, another 16. We're in the middle of trying to figure this stuff out. We're just starting our analysis. It's been a long time coming. A number of you have heard me talk about this for years, and what the heck is she doing? Of our 25 transects on the main stem, only 11 of them show an actual significant decline in exotic cover, and only 9 of them even have more than 20% native cover. What exactly that means yet, I don't know, but that's just some of what we're noticing on the main stem. I think one thing that's really important and really hard to work within fiscal years and budgeting cycles and grants is vegetation response takes a lot of time. Walked on one site the other day where we have a transect, and for the first time I'm seeing sagebrush seedlings. They're this tall. It's 4 inches. And it's going to be a long time before any of those get to any size where they're showing any amount of cover on the site. There's also a lot of uncontrollable factors out there: floods, droughts, fire, campers. And the other thing we haven't tried to control for, because we think it's part of what we have to learn from in our reach, is follow-up treatments, human uses, human changes to the site. I'm not saying to anyone you can't do anything here. We just want to track what happens as different events occur and then report those back. So hopefully in the coming months we'll have a whole lot more of interest to say about what we've been doing that might maybe answer some of our questions. The other thing is the extreme variability of site conditions. This is an example of transect number 5, 2005 high water, 2010 no water. I mean, walk out to the site in 2011 until almost October. So that makes it also hard to collect data in any significant repeatable way sometimes. I think this annual versus perennial issue is important, especially in vegetation. These photos, you're seeing kochia here. 4 years later, you're seeing almost no kochia. There's been maintenance of kochia in between. All that's happened is mowing. There was no maintenance of kochia in 2012. Now, granted, there was a drought, but still, it's interesting to watch the site. This is about 2 blocks from my house, so I will run this transect every year regardless of whether there's money or not. But I think that annuals are maybe overlooked in vegetation, and maybe they're usually less expensive seed. I think they can be a really important component in the seeding. So, again, if we answered our questions, this is kind of the biggie. I'm kind of thinking it kind of depends. So, I don't know if we've answered our question. I don't know if it's successful or not. A lot of these other questions, I think this was a really great brainstorming session. We don't have the funding, we don't have the capacity. Now, maybe some of our data can help with this, but I doubt it at some point. I think there's still really important, interesting questions that would be great to see research out there. Can we determine success or failure? Again, there's the time factor. Your trajectory of vegetation change over time, you can't see that in 1 or 2 years. And just looking at this site, you look at it 1 year, you look at it the next. That initial impression may have nothing to do with the long term where that site's trying to go. And I think the other critical piece that is you can't really even think about success or failure unless you're thinking about the goals of the property. It's completely subjective, and if it meets their needs, maybe it's doing okay, and maybe that's enough. But again, even in evaluating that, you need to give adequate time for writing it off as a failure. I've had sites that felt like a complete failure. I went up to Mill Creek in Moab, someone who was all hot and heavy about the problems. Walked around and I was like, wow, I haven't been here in 10 years. This place looks great. And she thought it was crazy. But it did look a lot better by simply time. If I'd gone and looked every year, maybe I would have never noticed those changes. So, thank you again to those who have helped with this. And if there's time for questions, great.